Good day, everyone. So today I'm going to talk about the project that focuses on and measuring alternating currents for AC. So it uses microcontroller, and this system is designed to help monitor the current drone household appliances or any electrical circuits in real time. So we know that we often take electricity. We often take electricity for granted until something goes wrong. And so pada sa kanang sudden blackout, or maybe an overload sockets, or a spike in electricity bill. So this project aims to address such as issues by giving a users a tool to monitor the current as consumption precisely. Also, and it is also affordably and of course safely. So so at this heart of this project is using PIC 16F877A microcontroller. So Kanisha is connected to a current sensor technically to current transformer, and which detects how much current is flowing through a wire. So this transformer generates analog signal to represent the current. So the microcontroller reads this analog signal using the built analog to digital converter or ADC. So Kanisha components converts the continuous analog voltage into a digital data that can be processed by the microcontroller. So the execution and function. So how it works. So once the analog signal is converted into digital values, so katulad siya ng microcontroller, so gina-perform niya mathematical operations to calculate the root mean square or RMS. So calculation of value for the AC current. So ang RMS daw is that the standard way for expressing an AC signal in terms of its equivalent to DC value. So kani siya is ginatell as sa atua how much usable the power being consumed. So to calculate, so ang calculation ano niya is that ang microcontroller, ang sample ato niya, ang AC waveform nakedly. So which means that each sample is squared. So because squaring makes all the values positive, help us to reflect ang power sa atong AC. So these squared values are then average, in average siya. And lastly is that the square root of this average is taken to obtain the RMS value. So the entire process is continuous in real time using embedded code, the program into the microcontroller. Then the result of the RMS current is displayed to the LCD screen so that the user can monitor it live. So um, importance sa the PIC microcontroller. So AC signals. So for this project is that AC signals are constantly changing for 50 to 60 times per second. So depending on time limitation. So measuring this fast and fluctuating signals. So accuracy is not possible. It's not possible with the simple analog tools. So the microcontroller. So this is the K. This is the spotlight of the microcontroller. So the PIC 16F877A ideal because Kanisha it has built the 10-bit ADC, so offers good resolution for analog signal conversion, and it's also relatively low cost and it consumes a very little power. So and of course this is programmable, which means that the performs real-time data processing, and it also display the control. So kani siya na mga features is system is compact, so affordable, reliable. So benefits to user. So kani siya in-home, so it helps us to use to track the electricity usage and reduce waste. Second is that it can detect overloads, so if the device draws too much current, the system can alert user and either trigger the protection response. And in industrial environments, so kani siya it used to monitor heavy machinery, so ensuring that tanan is operating within the safe current levels. Sa educational code, so that it can serve as a teaching tool for embedded systems and analog signal processing and power monitoring. So kani siya ng PIC Microcontroller basic project is a great example for how embedded system can solve practical problems. So using the simple controller turn sensor. So this is programming is created and real-time monitoring that is affordable, efficient, and user friendly. Thank you for your attention.